Okay, so this is lesson 2.2 for Mrs. Cucci's College Now Pre-Calculus class, so you should have file 2.2 open and ready to go. By the end of this lesson, you will be able to find the sum, the difference, the product, and the quotient of two functions, and determine the domains of the resulting functions. Find the difference quotient for a function. Now, the difference quotient for a function is something that you have never seen before, and this is going to lead into calculus, so it's very important that you pay attention to the second half of this lesson. All right, so sums, differences, and products and quotients of functions. A lot of this you've seen before. It's basically stating if you have two functions, f and g, and x is in the domain of each function, then if I have f plus g of x, it's the same thing as f of x plus g of x. Likewise for subtraction, multiplication, and division. This is something you guys have dealt with throughout the past couple years, so this is nothing new. Okay, so let's give one a shot. Given that f of x equals x plus 1 and g of x equals the square root of x plus 3, find each of the following. F plus g of x. So all that is f of x plus g of x. So we're just combining those two functions together. X plus 1 plus the square root of x plus 3. And since those are not like terms, we can't combine them. That's your answer. So f plus g of 6, you're going to find f of 6, and then you're going to add to it g of 6. F of 6 is 6 plus 1 plus g of 6, which is the square root of 6 plus 3. So we wind up with 7 plus the square root of 9, or 7 plus 3, which is 10. Okay, f plus g of negative 4, same process here. F of negative 4 plus g of negative 4. F of negative 4, you get negative 4 plus 1 plus negative 4 plus 3, square root of it. So you get negative 3 plus, we get negative 4 plus 3, which is negative 1. Square root of negative 1, hopefully you remember, is I. So we get negative 3 plus I. Okay, so hopefully you guys remember how to do that, and that's not a big deal. Now, if I were to look at this one graphically, we know that since it's an imaginary number, it doesn't exist on the real axes, x, y. Okay, that's when you have to use your imaginary and real. So this would not exist if we were talking about a domain from negative infinity to positive infinity. Okay. So sometimes it's helpful to look at the concept of the sum of two functions graphically. So what I have here is I have in blue f of x and in black g of x, or square root of x plus 3. Now if I were to take those two and I were to add them together, f of g of x, I get x plus 1 plus the square root of x plus 3, and we get our red line. Now, if I needed to come up with the domain of the sum of those two, it would be very easy to do it graphically because you can see what values of x are being used and what values of y. Okay? So we're going to get into a little bit of that as well. All right, so the domain there being negative 3 to infinity. The domain of f plus g is a set of all numbers in the intersection of the domains. So the intersection of the domains means what they have in common. Okay? So if we're talking about the domain of f, that domain would be in the entire number line. It's all the way from negative infinity to positive infinity. Your domain for g is going to be, since it's the square root of x plus 3, all right, square root of x plus 3, we know that this has to be greater than or equal to 0. So it's got to be greater than or equal to negative 3. Okay, and we should remember this from a few lessons ago. We did a whole bunch of these. So greater than or equal to is going to be shaded this way. We have -3 here just for a viewpoint. So if I want the domain of f plus g, it's everything that they have in common. Now what they have in common is going to be everything from this point of -3 back this way. Okay, so their domain is going to be everything from -3 to positive infinity. Okay, so it's what they have in common. It's their union or their intersection. Okay. All right. So when we're talking about domain, and domain is something that we are going to be doing a ton of this year, so you really do have to be comfortable with it, okay? If f and g are functions, then the domain of the functions f plus g and f minus g and f times g is the intersection. We just looked at that. The domain of f divided by g is also the intersection, but you also have to keep in mind any exclusions, because when you're dividing, g of x won't be able to be 0 because it would make my function undefined. So again, it is the intersection, but with an inclusion of any values that would make it undefined, an exclusion with any of the values that would make it undefined. So you have to keep that in mind when you're searching for domains. Okay, so given that f of x equals x squared minus 4 and g of x equals x plus 2, find the following. We want to find the domain of f plus g, f minus g, f times g, and f divided by g. So what we have here, x squared minus 4, you guys should know is a quadratic, and x plus 2 is linear. Okay? So if we're talking about domain, we're talking about the x values. All right? So with a parabola, you guys should know that my domain is all real numbers, all right? Negative infinity to positive infinity. With a straight line, again, negative infinity to positive infinity. So if we're talking about the domain for f plus g, again, it's the intersection of the domains, everything that they have in common, which is everything. F minus g is going to be the same. F times g, again, the same. F divided by g is the one we have to be careful of because we have to include any exclusions. So this f divided by g looks like this. Okay? We have to watch for the value of x that's going to make my function undefined, which by looking at it you should know is -2. Okay? So my domain for this one is going to go from negative infinity to -2, and then from -2 to infinity. So all of the values from negative infinity to positive infinity, excluding, that's why these are open, my value of -2, because that would make my function undefined. Okay, so I hope that helped. We're getting the hang of this. All right, so let's try another one. We just went over all of them. I'm sorry, I don't know why I have all these pages in there. Okay, given f of x equals x squared minus 4 and g of x equals x plus 2, find the following, g of x. Okay, so not nearly as difficult as you think it's going to be, right? We know what g of x is. G of x, this means g of x times g of x. So it's pretty simple for you guys to do. You know g of x is x plus 2 times g of x is x plus 2. So when we FOIL this out, we get x squared plus 4x plus 4. Again, it's a quadratic, okay? We know that for my domain for any quadratic, it's going to be all real numbers. We can plug in any value of x that we want, and we would never get this function to be undefined. Okay, so here comes the tricky part, difference quotients. Okay, f of x plus h minus f of x divided by x plus h minus x is called the difference quotient, or average rate of change. In calculus, it's important to be able to simplify these quotients, so we're going to do quite a bit of work with these. For the function f given by f of x equals 2x minus 3, find and simplify the difference quotient. So again, this is my difference quotient, right? We're going to plug what we know into this, okay? And I am going to need more space. 2x minus 3 is f of x. So there's my function. Here's my difference quotient. Okay, so what we're going to do is we are going to plug in for this piece here. Okay, normally we're used to seeing f of x. So this x plus h is what kind of bothers us. But all we're going to do is we're going to take our function f of x, 2x minus 3, and instead of writing x here, we're going to put 2 times x plus h minus 3. And then we're going to have minus f of x, which we know is 2x minus 3. And notice I put it in parentheses because we're subtracting a polynomial there. And then, oops, my board's a little off, x plus h minus x, that simplifies to h. So now what we need to do is deal with the algebra here. Okay, so we're going to distribute 2x plus 2h minus 3. Now distribute through that negative sign, minus 2x plus 3 all over h. Combine my like terms. I know those 2x's cancel and those 3's cancel. And I get 2h over h, which just reduces to 2. Okay? So it's really not that bad if you know what to plug in and then how do you do the algebra beyond that. Now, everybody's going to say, okay, so that's pretty easy. Does it get harder? Well, yeah. Okay, so let's try the next one. All right, so for the function f given by f of x equals 1 over x, find and simplify the difference quotient. So our function is 1 over x. Still have our difference quotient. Okay, and this is the already simplified version here. So now f of x plus h becomes 1 over x plus h, okay, minus f of x is 1 over x, over h. Now this is a complex fraction. You guys know how to work with complex fractions. We need to first deal with that numerator, right? We want to be able to do our little keep, change, flip thing that you guys know how to do. So what we need in the numerator is one fraction up there, which means we need common denominators. Now, x plus h and x are two completely different denominators. They're two different factors. So what I'm going to have to do is use both of them. So x times x plus h is going to be that common denominator. To get x times x plus h, I had to multiply this by x. To get x times x plus h, I had to multiply this by x plus h. Okay, over h. All right, so now we can keep, change, flip. And as I keep, change, flip, I'm going to distribute x minus h over x times x plus h times 1 over h. X minus x's cancel. So I get negative h over x times x plus h, 1 over h. Pardon me. My h's cancel. So what I'm left with is negative 1 over x times x plus h. And since nothing else simplifies here, that's it. That's my answer. Okay, so let's try one more. For the function 2x squared minus x minus 3, find and simplify the difference quotient. Okay, so our function f of x was 2x squared minus x minus 3. And again, our difference quotient f of x plus h minus f of x over h. So we're going to plug in. F of x plus h becomes 2 times x plus h squared minus x plus h minus 3. Notice I'm keeping my parentheses. Minus 2x squared minus x minus 3. Again, notice I'm keeping the parentheses over h. This we are going to have to FOIL out. Becomes 2 times x squared plus 2xh plus h squared minus x minus h, distribute that negative, minus 3. Now minus, you got to distribute here too, 2x squared plus x plus 3 all over h. We're going to distribute through our 2. So all I did was distribute through that first 2. Now we combine like terms. I have 2x squared and a negative 2x squared. Those cancel. I have minus x plus x. I have a minus 3 plus 3. And no other like terms. So we're going to rewrite what we have. I'm going to put it in descending order just because it's nicer that way. 2h squared plus 4xh minus h over h. And then in that numerator, I can do one more thing. We can pull out a GCF, okay? So we're going to take out that GCF. It becomes 2h plus 4x minus 1 over h. The h's cancel. And what I'm left with is 2h plus 4x minus 1. And that's it. Okay, so hopefully you have a pretty good grasp of finding the domains for functions that we add, subtract, multiply, and divide, and using this difference quotient to simplify. All right, so come prepared with any questions for the next class, and I will see you tomorrow. Thanks, guys.